this will be one of the fastest tutorial you've ever seen on object-oriented programming. I'll be very brief because I want to cover as much within the short possible time. So this is what I know about object-oriented. It's about objects that have behavior and state. So these objects that have behavior and state are being defined using what they call classes. So a simple class you can see is defined like this. So this is what a class looks like. So you have a class called box. And then in order for you to instantiate this class, that means make use that class in kind of creating instance. So you're going to be using this class to create instance. And the way you do it, for example, since you've created a class called box, you can, for example, say red box equal to box. So this is how you do it. So, and then from red box, you could also create a black box that is also equals to box. So when you create this box, so you're creating, it's more or less like this is the plan of the house, and here you're actually building the house. So this red box and black box that you created can also have attributes, more like you could attach attributes to them. So you could attach, for example, these are the attributes I'm attaching to them. So they are called instance attribute because these are instance of this class. So these attributes are called instance attributes. So for example, now I could decide to say print, and then we could print red box dot, you see, then we could print like the color. You see? So when we do this, it's going to print red. So we're going to see red here, down here. So you see red. So these are called instance attribute. So but the issue is, if we define an instance attribute like this, so when we define an instance attribute like this, why not we provide a mechanism in the class so that we could dynamically, when creating the instance, provide these attributes instead of defining it thereafter. So the way we do that is through this special technique. So I'm going to be showing you this. So this is how we initialize attributes for all instances. So this is what we do. So we create the class called box, and then we define the color, the length, and whatever this breadth is, and then we say self.color equals to color, self.length equals to length, and maybe self.breadth equals to breadth. So we define this attribute, and then when we want to instantiate our class or create instance of this box class, instead of doing it the way we did it previously, look at how we now do it. So this is called a dunder init method, or more or less like a method or a function in a class is called a method. So that helps us to initialize attributes of all instances of the class. So every single instance, for example, instance 1 here and instance 2 will have this attribute. When creating them, it will be a requirement for us to have this attribute on them. So the next thing we're going to be talking about is instance method. So instance method. So we've already seen one here, this method that is defined here in the class. So more or less called a constructor or an initializer of attributes. So now we want, what if we decide to have a custom method in this class? So how we decide to have another method, not an inbuilt method like this. This method comes, they are defined as part of the Python programming language, but I'm talking about our own method. How do we define a method that we can call, for example, with red box dot, for example, description. So we want a method that we can call like this on an instance of a class. So because we could call this method on this instance, then it's called an instance method. So that's what we want to define. And the way we do that, we're going to be defining that same method they call describe. So this is how the method is going to look like. So we're going to have this class box, but now you see we've added an extra method. You might see here that we have self.color, self.length, and self.breadth. The reason why we have the reason why we are using self here is because if you notice, whenever we try to print an attribute from the class, or we try to call a method like we did here, you have to do it from the instance. So let's see this self for now, just like a reference to the instance, so that later on we can replace this self with, say, red box or black box. So if you want to call this instance, so let's initialize, let's create the instance of the class now. You see, so same like we did the other time. So we're going to be creating the instance of the class here, and then look at how we've created the instance of the class. Now we can call the instance method that we created. So you see, so now we are calling the instance method describe. So we can call it from both instances of the class that we created here. So let's execute this and see what happens. So you see, so box, color, black, length 60, breadth 60, just the way we provided it here for the black one. And for the red, you see we have red, length 56, and breadth 60. So the next thing we are going to be introducing is how do we then, so if we say, for example, color is an instance attribute, what if we've defined instance attribute, and also we've defined an instance method. So what if we want an attribute to be attached to the class, but not to specific instances like the red box and black box? We want something like box dot. So the way we achieve that, for example, is using what they call a class attribute. So I'm going to be defining one here. So if you look at this one I defined, still a modification of our box class. So here I am creating a class attribute here called counter. And what I'm doing is that each time I create an instance of this box class, I want to update the value of this counter. So this counter is not going to be attached to the instances. So it's not going to be, for example, attached to the red box or the black box that we created. So it's not going to be attached to this red box or this black box. Although when we print the breadth here and the height, we get different value. But you discover here that because we've created two instances, each time we create an instance, the box.counter is being updated. And you can see here that here we are going to have the value of breadth for red box to be 70 and the value of breadth for black box to be 60, while the red box.counter would be 2 because we created two instances. Because each time this initialization method is being called, this counter is being updated. So let's execute this and see what happens. So you see here that we have 70, 60, 2 because, and you discover that this counter is attached to this class. It is not to a specific instance because each time we create an instance, it's updating. It's not specifically aligned to an instance. So the next thing, we've seen how we have defined an instance method. So this self that we passed here shows that it's an instance method. So you could see here that we've defined an instance attributes here, an instance method. So now we also defined a class attribute. So now we want to go as far as defining a class method. So a method that is attached to a class. And the way we do that is by doing this. So we're going to be updating the definition of our class to look like this. So here, what I'm actually doing here is still the same class, but now I've added a method here. So I've added a method here. This method with this special decorator is what you call a class method. This method is not directly linked to these instances that we're going to be creating. So these instances like the black box and the red box, this method are directly referencing the class. So let's see how we can call this method. So what I'm going to be doing here is that I'm going to be creating the instances still like I did the other time. So this, I'm creating the instances and I'm calling the instance method. Look at the word instance method. So I'm calling the instance method. Now, how do we now call the class method? So in order for us to close the class method, let's see what we did here. So if you look at the definition for the class method here, we said it's going to be creating an instance of box. So that means it's going to be creating a box the same way we did here. So it's going to be returning this kind of, it's going to be creating a new box. You see, this is like creating a new box that will be white. So default box that will be white. So here we're actually creating the white box with the box.create method. Look at how we're calling it. We are not calling it on red box or black box, which are instances. Rather, we are calling it on box. We are saying box dot. We are directly referencing the class here, box, when we call the methods. That's why we call it a class method. But for this method here, you see, we are calling it on the instance. These are instances that are created from the class box. So that is why we call it instance method here. And these ones are class method. The next thing we're going to be looking on is the concept of static methods. Let's say, for example, so we've talked about both the class and the instances. So we use the class to instantiate the instances, to create the instances. So via the class. And we've also discovered that methods could be attached to instances and methods could be attached to class. What if we don't want these both scenarios? We just want a container. So for example, I just want a class here. So a class here. And this class, I just want it to contain some generators. So there will be some generators in this class. So it's just going to be like a container to hold my methods. So basically, I'm going to have a method here. So this method is going to generate some numbers. So I have a method here that generates some numbers. So you see, so this is a method. So in order for me to kind of like just use this method, just like any other function that I've created somewhere, it's not attached to this class generator, but it's just a standalone function. I'm just using this class generator more or less like a container to house this class. So I have to put a special decorator also called a static method. So that means it's just a static method. So you see the random functions is being used here. So I'm going to import it here. So I'm going to say import random. because I'm using the random function here. What it's doing is that I'm going to be selecting a choice of a number between the range, the start and the end. So let's see how we can use this static method. So the way we do it is by just doing something like this. So we're going to be saying something like my number, and this my number is going to be equals to, say, we call the class, so generators, then we just say dot generate numbers. So you see, and then we pass in the start and the end. So let's just pass in like 1,000 here and like 3,000 as the end. So when we decide to print this number here, so let's try to print this number here, my num, you discover that my num is going to keep generating random numbers each time. So the goal here is not just to talk about the function, but to talk about the fact here. In this case, the generator is just serving as a container for us to house the static method. So we could also have like another static method also attached to that one. Let's say we can have multiples of static method, not just that. So this is a static method that generates. So this one is going to be generating random names each time we call it from this list of names. So we could also call it the same way we call this one. So we could also generators dot generate this time around names. This one doesn't take any argument, so we can just let's just say my. So let's call it a little bit differently, my name, and then let's execute this. You see, we get Avery as a name, and when we execute it again, we get Elijah. So you see, basically what I'm trying to show you is that here we are just using these generators as saying these are functions that generate numbers, because the functions do similar things. We are just putting them inside this container, but this doesn't look like when we were trying to kind of like attach methods to instances. So what I'm going to do after now is try to create an example where I'm going to use object-oriented programming, just like the last video. So you could check the last video where I kind of like use a collection of functions to build a CSV generator. So let's look at this example. So in this example now, I'm going to be talking about a concept called inheritance. So here, for example, you could see here that I have a class called ship. So this is a class called ship. So let's look at the class. So the class is called shape. It's actually like a modification of the class for box, but now we're calling it shape, and it's having some length and some height. So here we are also having the counter method, and then we're having this instance method called describe here. And then we're also having the same class method here that creates a box. So let's change this one to like, it will be creating some shape. So let's say this is going to be creating some shape. Basically here, we just want to show what it means. So to inherit from a class. So here we're having this class called shape with this definition. So we could actually create another class called square, so that inherit from this class. So you see, so we're creating another class called square. So basically this class inherits from shape. So this shape is the parent to this class square. Square is a child to shape. So it has inherited from shape. And what this means is that we can, for example, create a square. This pass showed that we did not put any definition. It's more or less showing that this is empty. But look at what is happening here. We are creating a square. So we're saying square 1 equals to square. And then what we are doing now is that we are calling the describe method on this square, even if when the square is empty. So we are creating an instance of square. So it's inheriting this constructor here, the same way this constructor was. It's also inheriting this describe method. Look at now, we are calling it on square because it has inherited all the definitions that are defined here. So let's execute this. And you see, it's working. Look at it, printed the shape. So this is where I've come to the end of this object-oriented showpiece. So so what I'm going to do following this is that I'm going to come up with practical examples, and also we will deepen our understanding of object-oriented programming in future videos. So thank you for listening. If you like my content, I want you to subscribe to my channel. I like what I'm doing right now, and I will keep bringing more videos, even more videos on some very important topics as time goes on. So thank you.